Good morning, students. Today we are going to read the graphs of sin x, cos x, tan x, and their reciprocals of like sin's reciprocal is cosecant, cos reciprocal is secant, and tan's reciprocal is cotangent. So first graph that we are going to read is of sin x and cos x. So concentrate yourself. The diagram shows the graph of y is equal to cos x. So this is the graph of cos x for x is greater than or equal to minus 2 pi, lesser than or equal to 2 pi. So the limit is from minus 2 pi to plus 2 pi. Or we could use minus 360 degree to plus 360 degree in case x is in degrees. Okay. When x is 0, cos and secant is 1. So cos 0 is 1. So look now. So cos 0 is 1. So because cos theta is equal to 1 over secant theta. So if secant theta will become now cos x will become to the denominator of right side. So because cos is 1, so 1 over 1. So if cos 0 is 1, then secant 0 will also be 1, putting value of cos 0 over here. So 1 over 1 will be 1. So this is the thing. So look now. In case x, okay, when x is equal to 0, cos x and secant x is 1. When cos x is equal to pi, cos x and secant x is minus 1. So look now. Because cos pi is minus 1 and secant is equal to 1 over cos. So putting value of cos over here, so 1 over minus 1 will be equal to minus 1. So if cos pi is minus 1, secant pi will also be minus 1. So here is the thing. When x is equal to pi, cos x is equal to secant x is equal to minus 1. Okay, when x is equal to pi by 2, cos x is 0 and we cannot calculate secant x. So look now, because we know cos 0 is 1. Okay, when pi by 2, sorry. So when cos pi by 2, cos pi by 2 is 0. So secant is equal to 1 over cos theta. So 1 over 0, this will be infinity, which is undefined. So this is the thing. So when x is equal to pi by 2, cos 0 is 1, cos pi by 2 is 0, and we cannot calculate secant x. When cos x is small and positive, okay, when cos x is small and positive, secant x will be large and positive. So another concept is here that is used. So look now, secant theta is equal to 1 over cos theta, and because you are in A levels now, so if we put smaller value over here, so 1 over smaller value, answer will be, so look now, 1 over smaller, the answer will be greater. And if we put greater value over here, the answer will be 1 over greater will be smaller. So this is the concept which is used here. So when cos x is small and positive, secant x will be large and positive. When cos x is small and negative, secant x will be large and negative. Because the cosine graph is periodic with period 2 pi, so because it is periodic 2 pi, So 2 is the graph of secant x. So this was the graph of cos and secant x. Now we are going to discuss the graph of sin x and cosecant x. So concentrate yourself. The same concepts will be used as you have studied in the graphs of cos x and secant x. So look now. The diagram shows the graph of y is equal to sin x. So this is the graph of y is equal to sin x and y is equal to cosecant x, and these are the graphs of y is equal to cosecant x. So this is the graph of y is equal to cosecant x, and this is the graph of y is equal to sin x for minus 2 pi to plus 2 pi. So limit is from minus 2 pi to plus 2 pi. Okay, when x is equal to pi by 2, sine and cosecant x will be 1. So look now, because sine pi by 2 is 1, and we know cosecant x is equal to 1 over sine x. So putting value of sine over here, so 1 over 1 will be equal to 1. So this is the thing which is used here. Sine x and cosecant x is 1 when x is equal to pi by 2. Okay, when x is equal to 3 pi by 2, 3 pi by 2 is 270 degree. Cos x and cosecant x are minus 1. So look now, sine 0 0 and sine 91. Students, here the thing is wrongly put. Cos, this is sine, so sine and cosecant, so this was misprinted over here. So look now, when x is equal to 3 pi by 2, so sine 3 pi by 2, this is minus 1, and cosecant is 1 over sine. So when we put the value of sine in denominator, cosecant will also be minus. So sine pi by 2, so when x is equal to pi by 2, sine x and cosecant x will be minus 1. So this is the concept. Okay, when x is equal to 0, sine x is equal to 0, and we cannot calculate cosecant x. So look now, this is the concept. So when sine x is, okay, sine 0 is 0 when x is equal to 0, and cosecant is equal to 1 over sine. Putting value of sine in denominator, so 1 over 0 is equal to undefined. So it means when x is equal to 0, sine x is 0 and cosecant x is undefined. So this is the concept which is used here. So when x is equal to 0, sine x is 0, and we cannot calculate cosecant x. When sine x is small and positive, cosecant x will be large and positive. When sine x is small and negative, cosecant x will be large and negative. This concept I have told you earlier. So look now, in denominator, if there is a smaller value, so the fraction's answer will be greater, and if there is greater value in the fraction in the denominator of the fraction, the answer of the fraction will be smaller. So this is the fact which is used here. When sine x is small and positive, cosecant x will be large and negative, because the sine graph is periodic with period 2 pi. So 2 is the graph of the cosecant x. So both are periodic of 2 pi. So this was the graph of sine x and cosecant x. Now finally we are going to discuss the graphs of tan x and its reciprocal cotangent x. So look now, the diagram below shows the graph of the y is equal to 10x. This is the graph of y is equal to 10x for limit minus 2 pi to plus 2 pi. The diagram below shows the graph of y is equal to cotangent x. So cotangent is the reciprocal, so the direction will be entirely opposite. So if this graph is like this, so this graph will be like this. In the same limit minus 2 pi to plus 2 pi. When x is small and positive just above 0, so 2 is 10x. So cotangent x will be large and positive. When x is close to 2 pi by 2, the value of 10x is very large and positive, and so cotangent x will be very small. All concepts has been discussed in the graphs of sine and cos x. Okay, because the tangent graph is periodic with period pi, so 2 is the graph of cot x. Good morning, students. Our today's topic in the subject of pure mathematics 3 is trigonometry. And in trigonometry, we are going to read trigonometric identities. So first you have to understand and learn some formulas without which you will be unable to solve the questions of trigonometrical identities. So the first formula is tan theta is equal to sine theta over cos theta. Second formula is sine square theta plus cos square theta is equal to 1. Next is 1 plus tan square theta is equal to secant square theta. Next is 1 plus cotangent square theta is equal to cosecant square theta. Also, you have to remember that sine theta is the reciprocal of cosecant theta. Cos theta is reciprocal of secant theta, and tan theta is reciprocal of cotangent theta. So if cotangent theta and tan theta are reciprocal of each other, so if tan theta is equal to sine theta over cos theta, so definitely cotangent theta will become cos theta over sine theta. At the same time, you have to remember some more things, that is, if sine theta is equal to perpendicular over hypotenuse, so cosecant theta will be equal to hypotenuse over perpendicular. Likewise, if cos theta is equal to base over hypotenuse, then secant theta will be equal to hypotenuse over base. And lastly, if tan theta is equal to perpendicular over base, so cotangent theta will be equal to base over perpendicular. So these are some formulas that you have to understand and learn before starting the topic trigonometrical identities. So first remember and learn these questions, these formulas, and now we are going to solve some questions. So active now. Now here is a question that the requirement is proof. So it means the left hand side has to be proved equal to right hand side. So we are taking the left hand side. So the left hand side is tan square theta plus cot square theta plus 2. So we are breaking this 2 into 1 plus 1, and 1 will be added with this one, 1 plus tan square theta, and 1 will be added with this 1 plus, and this will become 1 plus cot square theta. So the reason is actually left hand side is equal to right hand side, and right hand side I'm seeing that there is cosecant and secant. So actually these formulas will be used. 1 plus tan square theta is equal to secant square theta, and 1 plus cot square theta is equal to cosecant square theta. So look now, this factor is has become 1 plus tan square theta is equal to secant square theta, and here plus is there, and this will become 1 plus cotangent is equal to cosecant. So look now, the shape is coming So 1 plus secant square theta is equal to, okay, secant is reciprocal of, look now, reciprocal of cos, and cosecant is reciprocal of sine. So it means a 1 over cos square theta will be equal to this one, and 1 over sine square theta will be equal to cosecant square theta. At this step, we are going to take the LCM. So sine square theta, cos square theta will be the LCM. Here will come sine square theta, and here will come cos square theta. So in the next step, because sine square theta and cos square plus cos square theta is equal to 1, and in denominator we are having now sine square theta, cos square theta. Okay, and the very final step, sine square theta is the reciprocal of cosecant square theta, and cos square is the reciprocal of secant square theta. So this is the thing which is proved. So it means we have proved it to right hand side. Here is another question. Statement is solve for x greater than or equal to 0, lesser than or equal to 360, and the question is secant square theta is equal to 10x plus 1. Okay, first there are actually two different trigonometrical identities. So first we have to convert them into single one. So we know 1 plus tan square theta is equal to secant square theta. So we will put 1 plus tan square theta in place of secant square theta, and right side will remain as it is, that is tan theta plus 3. Actually there are x, not theta, so we will write x as well. So 10x plus 3. In this step now you can see only 10 is the trigonometrical ratio that is involving in the question. So now the question will be easy to handle. So 10 square x, this 10x will come to the left side, and this plus 3 will come also to the left side and will become minus 2 because plus 1 is there. Okay, this is the equation now, and this is a quadratic equation which can be solved by factorization or quadratic formula method. So multiply the coefficient of first one with the last one, that is 2, and the central coefficient is a 1. So it means we have to think a pair of numbers whose multiplication equal to 2 and addition or subtraction is equal to 1. So these are actually 2 and 1 numbers, because 2 ones are 2 and 2 minus 1 is 1. The central value, the central variable, that is actually 10x, will be written with both of these numbers. This sign is telling us that these two values will have opposite signs, and this sign is telling us that the larger one will have minus, and definitely opposite will have the smaller one. Okay, now we are going to put this factor in place of the central value. So look now, 10 square x minus 2 10x plus 10x, this minus 2 equal to 0 will remain as it is. At this step we will make pairs and take common. In first pair 10x is common, the remainder is 10x minus 2. In second pair plus 1 is common, the remainder is 10x minus 2, equal to 0 is still there. Out of these two common brackets, a one bracket will be copied. So 10x minus 2 and the values outside the bracket will be copied in the second bracket. So 10x plus 1 equal to 0 is still there. From here 10x minus 2 will be equal to 0, or 10x plus 1 will be equal to 0. From here 10x will be equal to 2, and from here 10x will be equal to minus 1. So because 10 is positive, so 10 is positive in all student take. So 10 is positive in first and third quadrant. So here is basic angle, and from here basic angle will be equal to 10 inverse 2. So 10 inverse 2 is equal to 63.43. Okay, now we are going here. Okay, from here the original angle x will be equal to alpha and 180 plus alpha. So because alpha is 63.43, so 63 plus 43 plus 180 is 243.43. Okay, now come here. Because 10 is negative, so all student take chemistry. So second and fourth quadrant will be there for this thing, because 10 is negative in second and fourth. So here is the basic angle. Okay, the basic angle is alpha is 10 inverse 1, because the function of the minus was to decide the quadrants. Okay, now 10 inverse 1, the answer is 45. Okay, now the original angle, that is x. X is 180 minus alpha and 360 minus alpha. So 180 minus alpha and 360 minus alpha. So the x angles will be 180 minus 35 will be, 45 will be 135, and 360 minus 45 will be 315. So this is the solution. Here is another question, and this statement is solve for x greater than or equal to 0, lesser than or equal to 360 cotangent square x minus 5 cosecant x plus 7 equal to 0. Again, there are two different trigonometrical ratios. So first we have to convert them into single ones. So look now, cotangent square x. So this is the formula. 1 plus cot square is cot square theta is equal to cosecant square theta. So this cot square theta will be equal to cosecant square theta minus 1. So cosecant square x minus 1, this minus 5. Cosecant x plus 7 equal to 0 is still there. So from here, simplify the equation. Cosecant square x minus 5 cosecant x minus 1 plus 7 will be plus 6 equal to 0 is still there. So now the equation has become into one trigonometrical ratio. So this is a quadratic equation now. We will solve it by factorization or quadratic formula method. So multiply the coefficient of the first one with the last one. So it is 6. Central coefficient is 5. So think a pair of numbers whose multiplication equal to 6, addition or subtraction equal to 5. So these are actually 6 and 1. Okay. Because 6 ones are 6 and 6 minus 1 will be 5. So this sign is telling us that both will have same sign. So these factors, there is another option that will be applied here. So 3 2s are 6. So these are the numbers because these will fulfill the further conditions. Okay, now we will write the variable, central variable with these two numbers. Okay, this sign is telling us that both will have same sign, and this sign is telling us that both will have minus sign. So now we will put this factor in place of the central value. So it will become now cosecant square x minus 3 cosecant x minus 2 cosecant x. This plus 6 equal to 0 will remain as it is. At this step, you will make pairs and take common. In first pair, cosecant x is common. Remainder is cosecant x minus 3. In second pair, minus 2 is common. Remainder will be cosecant x minus 3 equal to 0 is still there. Out of these two common brackets, you will write one bracket. So cosecant x minus 3, and the values which are outside the bracket will be written in the second bracket. So cosecant x minus 2 equal to 0 is still there. From here, cosecant x minus 3 equal to 0, or cosecant x minus 2 equal to 0. Okay, from here, cosecant x is equal to 3, and from here, cosecant x is equal to 2. Okay, because cosecant is positive, cosecant is actually sine. So in first and second quadrant, sine and cosecant are positive. So here will be the basic angle. Okay. Now we will solve the rest of the question here. So because cosecant x is equal to 3 and cosecant is equal to 1 over sine, so 1 over sine x is equal to 3, and sine x will be equal to 1 by 3. Okay, from here, basic angle alpha will be equal to sine inverse 1 by 3. So sine inverse 1 by 3 is 19.47. Okay. Now the original angle x will be equal to alpha and 180 minus alpha. So alpha and 180 minus alpha. So the answers will be 19.47, and 180 minus 19.47 will be equal to 160.53. Okay, from here now, cosecant x is equal to 2, cosecant is equal to 1 over sine, 1 over sine x is equal to 2, 1 over sine x is equal to 1 over sine, 1 over sine x is equal to 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 1 over sine is equal to 2. From here, sine x is equal to 1 by 2. Okay, alpha will be equal to sine inverse 1 by 2, and sine inverse 1 by 2 is 30. And because cosecant is positive, so again first and second quadrant will be for positive cosecant. Okay, again alpha and 180 alpha, 180 minus alpha will be the angles. So original angle is alpha and 180 minus alpha. So alpha is 30 and 180 minus 30 will be equal to 150. So this is the solution of this question. Here is a question, prove that first part is cot x plus cosecant x whole square is equal to 1 plus cos x over 1 minus cos x. And hence solve the equation. So this equation is now equal to 2 for this. So from here you must be alert that the requirement is in radian mode. So first you have to change your calculator into radian mode. Okay, here is the solution. So we are going to solve it now. Cot x and cosecant x are there. Okay, first take the left hand side, that is cot x plus cosecant x whole square. Okay, from here cot is equal to cos over sine, and cosecant is the reciprocal of sine. This whole square is still there. So taking LCM, sine x is the LCM. In the numerator we will have 1 plus cos x. Whole square is still there. So from this step, numerator will remain as it is, because actually we want to go there. So 1 plus cos x whole square, numerator will remain as it is, and we are taking the square of the denominator, that will be equal to sine square x. And in next step, 1 plus cos x whole square will remain as it is, and sine square x is equal to 1 minus cos square x. In denominator we have two squares, in between minus, so a square minus b square formula will be applied. So look now, 1 plus cos x whole square, numerator is as it is, and in denominator we have 1 plus cos x into 1 minus cos x. And 1 plus cos x, one value will be cancelled by this, because in the numerator we have 1 plus cos x 2 times. So the remainder is 1 plus cos x in the numerator, and in the denominator 1 minus cos x, which has been proved equal to right hand side. Okay, in the second part, the requirement is hence solve the equation. This is equal to 2 for this range. Okay, because this thing is equal to now this thing, so it means second part, 1 plus cos x over 1 minus cos x is equal to 2 now, because this is the thing which is given. From here cross multiply the values, so 1 plus cos x is equal to 2 minus 2 cos x. From here this minus 2x cos x will come to the left side, and it will become 3 cos x. This one will go to the right side. From here cos x is equal to 1 by 3. because cos is positive and cos is positive in first. All students take chemistry and fourth. So cos is positive in first and fourth quadrant. So here are the basic angles, and basic angle will be equal to cos inverse 1 by 3. So alpha will be equal to, first convert your calculator in radian mode now. Okay, because range is in radian mode. So cos inverse 1 by 3. Answer is 1.23. Okay. Now the original angle is x. That will be equal to alpha, and so this is 0 and 2 pi. So alpha and 2 pi minus alpha. Alpha and 2 pi minus alpha. So alpha is 1.23 and 2 pi minus, so 2 pi minus 1.23. This is equal to 5.05. So this is the solution of this equation.